Hi guys, we know there is fading phenomena for electromagnetic signals during propagation in free space. What is the transmission loss of fading if we insert two horn antennas with 2 meters distance into a 65 GHz signal path? Firstly, let's take a look at the output power of this 65 GHz signal. We use a frequency multiplier to create this 65 GHz signal. The signal generator's frequency multiplication is set to 4. So we can set the frequency to 65 GHz directly, and the output power is set to 6 dBm. The extender works at full saturation and outputs a constant power. The automatic level control loop is not configured for the current devices. So an attenuator is used to adjust the outputs. After calibration, we connect the power sensor to the extender. We set the attenuator to 35 dB. The reading is minus 20.4 dBm. We set the attenuation to 30 dB, to 25 dB, 20 dB, 15 dB, 10, 5, 0 dB, no attenuation. Now, the power meter reads 15.5 dB. Actually, the extender's output power is more than 15 dBm. But you can see there are two straight waveguides with about 1 dB attenuation in the path. Secondly, let's use two pyramid horn antennas to check the transmission loss for 2 meters distance. The antenna has a gain of 23 dBi. One antenna is connected to the frequency extender. We keep the attenuator in the path to adjust the output power. 2 meters away is a receiver antenna. The two antennas are placed in a straight line, mouth to mouth. At the signal receiving side, a spectrum analyzer extender is used to down-convert the signal. The spectrum analyzer can automatically detect the module and make the proper configurations. Now, the attenuator is set to 0 dB. The peak reading is minus 13.9 dBm. We know the transmission loss is about 28.5 dB. We keep increasing the attenuation to 5 dB, 10 dB, 15 dB, 20 dB, 25 dB, 30, 35 dB. Now we can see the peak reading is about minus 48.4 dBm. We change the span to 10 GHz. Then to 20 GHz. We press the peak button. We can see the peak remains at about minus 48.4 dBm. We can also see there's no other signals on the screen. In this test, we use a continuous wave signal. We can also use other modulated signals to characterize the space fading for different modulation types. That's all.